Okay, guys, so yesterday we spoke, right, about fractions and decimals. There's a reason we spoke about that as we start this new chapter, because they are what's considered, or many of them anyway, are considered rational numbers. All right, so that's kind of where we're going with this chapter, actually, is rational numbers. And this is just kind of an intro to what rational numbers are. And we're going to kind of take a look at some of those during this lesson. So here we go. Actually, we only have one phrase, and that is rational numbers. Everyone?
Rational numbers.
All right, so here's what rational numbers are. The book says it's the set of numbers that can be written as a fraction in the form a over b, where a and b are integers, and b is not equal to 0. Okay, I know it's kind of lengthy, right? That's a nice in-depth look at what rational numbers are, and that's what your book says it is. Okay? Here is kind of an easier way to remember it. Okay? Rational numbers are decimals, or of course fractions when you convert it to a decimal, that are either terminating or repeating. Which of course, decimals that are not terminating nor repeating, which means a decimal that goes on forever without repeating, that's not a rational number. Okay. Okay. All right, so with that said, go ahead and grab a piece of line paper. We're going to get into rational numbers and some of our examples that we'll see in our book today. So a piece of paper. Go ahead, put your first and last name up at the top. Period, assignment number, date. Most of you guys are getting pretty good at making sure all that info's up there. Page number. All right, if you haven't already done it, make sure that you flip over to page 104. 104. Okay, let's go ahead and start with problem number 13. Let's take a look at 13. Okay. Now, number 13, I'm going to go ahead and do it up here. Number 13 is negative 10 and 7/8. And of course, we need to read the directions to understand what we need to do with that. So here we go. The directions say write each number as a fraction. Some people would argue, well, Mr. Wilkins, that is a fraction. Well, yeah, but the fraction part is here. We have a whole number, a whole integer in front, which they consider a mixed number. Okay, so we need to convert it to a fraction, which means we're going to need to put it basically into an improper fraction. So basically, I'll put steps here. Okay, step 1, remember, is you multiply the denominator with the whole number. This is, of course, an algorithm, a quick way of doing it. So 8 times 10 is 80. And then step 2 is, of course, you add the top, right? So we have 80 plus 7 is 87. So after you add, I'll just keep this as part of step 2. We write that's our numerator. So 8 times 10 is 80, plus 7 is 87. Okay, step 3. I'll put the word same here, because the denominator, guys, it remains the same. It's still 8. Now, I'll go ahead and we won't even call this a step. We'll just say, well, we'll call it step star, but that is, remember, if it is a negative fraction or mixed number, then the other one, mixed number or fraction, needs to be a negative when you're converting it. Okay. So that's that's it. All right, it kind of starts off with some easy problems. I just wanted to make sure, since some of us, it's maybe been a little while since converting one of those, I wanted to make sure we remembered how to do a mixed number to a improper fraction. Okay. So, really quickly, take a look at number 12. How would you make that into a improper fraction? Yeah, put it over 1. That's all you have to do. Okay? So I don't want anyone to get confused about that, right? That just those whole numbers, you just put them over 1. Okay, so let's get actually into more of a 7th, 8th grade problem. All right, and that is, and this isn't, you probably did this in elementary school as well, but let's review this one. So it's number 18. The directions say write each decimal as a fraction or mixed number in simplest form. So we are converting. Yesterday we used a calculator to convert our fractions to decimals. Now we're going the other way. So we have what they give us for number 18 is negative 265 thousandths. Negative 265 thousandths. So here we go. Step 1. Step 1 is always probably the easiest to get the denominator. Now, if you are good at knowing your place value, and it's right up on our wall right there as a reminder, but if you're good at knowing your place value system, then you will be able to verbally say this out loud and know exactly what your denominator is. So for example, it is negative, then you say the number right to the right of the decimal, 265, and then remember this right here is your thousandths. That's actually your denominator. However, if you're not good, hopefully all of you guys are good at knowing your place value. If you're not good at it, here's another way of doing it, is if you count how many digits are to the right of the decimal, there's 3 of them, that also would tell you how many zeros to put behind your 1 for your denominator. You see that? So 3 digits, 3 zeros. Okay. Now step 2 is you take the number, the decimal part. Okay, what I mean by decimal is everything to the right of the 0 and the decimal point, and you place it as your numerator. So in this case, 265. And then there is step 3, and that is you need to reduce or simplify. Okay, this is where divisibility rules come in. We can use a simpler divisibility rule here. It ends in a 5 and a 0, so I know that I can divide it by 5. So today you'll need to show your work, okay, on your reducing. So 5 goes into 10 2 times with 2 extra zeros. Okay, so 1,000 divided by 5 is 200. If you needed to go to the side, use scratch paper work. I'm okay with that, like this next one. 5 into 265. That goes in 5 times, 25, 1, 15, 3 times 15. So it is 53 as a numerator. Now this, of course, we can't forget what we can call step star again, right? Same as step star last time is don't forget to transfer that negative over. Don't forget to transfer that negative over. Now remember, step 3 might be a long process. If this was like 55 over 200, I could have reduced it again. Okay, or of course you could reduce by a larger number at the very beginning. Okay. Okay. Questions about converting a decimal to a fraction? I'll have you guys try one. You ready? All right, here we go. Problem 16. Problem 16. Go. Okay, anyone need more time on that problem? Okay, 30 seconds. Go ahead and turn to your neighbor. See if you guys got the same thing.
I got a little over 20.
All right, really quickly, just looking for an answer. All right, seat 9. What'd you get?
I got 11 over 20.
11 20ths. Agree, disagree? Okay. All right, well, let's check it out. All right, most of you agree, so let's see if you guys are right. So, number 16, we have 5500ths. So, when I write it, right, I could write 5500ths, the words that are coming out of my mouth, or, of course, there's 2 digits, put 2 zeros, it means it's creating 100, and put the 55 on top. Of course, with this one, they end in a 5 and 0, so I can reduce by 5 here and get 11 20ths. 11's prime, so I can't reduce anymore. There is no negative, so there we go. Nicely done. Okay. Questions on those kind of problems? You guys all right? Okay, here we go. Let's go ahead and take a look at problem 26. 26. Okay, so on 26, I'm going to go ahead and go up to this space up here. Okay, on problem 26, it says write each decimal as a fraction or a mixed number in simplest form. So we have 9 and 2700ths, but it is in bar notation. In bar notation. Okay? So, first off, okay, step 1 is if there is a whole number, even if it's a negative, all right, put a little step star combined with this, just move it down to your answer. That's your whole number. It's going to be a mixed number because you have a whole number in front of the decimal. Okay? Now, that part's easy, right? Step 2, though, is we're going to go ahead and take a look. Now, with this part, if it's a repeating decimal in bar notation, okay, it's actually quite easy. I guess I should have maybe made this like a bubble or like a little brain or something, because part of this should be mental math. Okay, here's what you do. If we were to do it the way we just did it earlier, it would be, what would it have been? 27 over 100, right? Because you have 2 digits, or 2700ths. Okay. However, the numerator ends up being the same. It's still 27. The denominator is what's different. To actually create the bar notation for it to repeat, you actually take 1 off of your denominator. So instead of 100, it's 99. Okay? Now, step 3, you still need to reduce the fraction part of your mixed number. Okay? So if I look here, what I do know right off the bat, 27 and 99 both are divisible by 9. So I'm going to go ahead and write the whole number is 9, 27 divided by 9 is 3, 99 divided by 9 is 11, and there it is. Okay, now listen. If you're looking at step 2 and how the denominator becomes a 99, when I said you take what you usually would have, but you subtract 1 from the denominator, okay? That is ultimately what happens. That's like an algorithm. That is a quick way of getting to an answer, okay? However, the reason why I'm just giving that to you is this time of year, we haven't talked deeply about equations, but if you have a good grasp on equations, even though we haven't talked about them this year, you remember them from elementary school and you want to get a good idea of why that is, there's actually an explanation on page 102 of your book. So not right now, but in the future, if you want to see how that becomes a 99 rather than 100, the explanation will show. Okay, if you want me to go over it later on after we talk about equations, I will gladly do it. Okay, but I don't want to spend time doing it right now. This is what you mainly need to realize for right now. Okay, so any questions about that, guys? Okay, here's a question. So if this, let me make sure I'm in here. If this right here was 9.27, this would really be 9 and 27 100ths, right? Kind of like what we were talking about. But instead of being 99 because of the bar notation, to create that in your fraction, I'm saying it's not out of 100. You take 1 away from here, it's out of 99. Okay, other questions?
For the whole number, even if it's negative, would it turn into positive or stay negative?
No, it'd stay a negative. It'd stay a negative, yeah.
Will the denominator always be 99?
For 2-digit numbers, that's, yeah. Okay. I do want to say this, though. Okay. You see that how this whole thing is in bar notation? If only a part of its bar notation, this rule doesn't work exactly like this, okay? You would need an equation. That's why I took out part of your homework assignment, is because it might have had like 9.127. The 1 wasn't a repeating, only the 27 was, okay? So in that case, you'd have to use the equation, but we're not going to worry about that this year, okay? So you're only doing it where the whole decimal part to the right of the decimal point, that's all in bar notation. And I didn't give you any homework that wasn't like that, so you'll see that.
Okay, so what if say you're doing a question that's like that, and so you do the denominator and the numerator, but it doesn't have one like the multiplication things. What would you do after that?
Meaning you can't reduce? Mm-hmm. There's your answer. So if you can't reduce, that's your final answer. You're good to go. Just box it in. Just make sure you can't reduce before you say it's your final answer. But yeah, that would be it. Okay, here we go. Problem 28. Try out problem 28 on your own. Okay, go. Okay, anyone still working on that problem? Okay, give you guys about 15 more seconds. If you're already done with it, move on to some other similar problems where you can work on those. Okay. All right, 30 seconds. Go ahead and turn to a neighbor and share. Go.
I got negative 11, 74 over.
Oh, it's I said negative 10.
'All right, let's check in on a possible answer from you guys. What do I do with my popsicle sticks? Am I overlooking it? Oh, they're covered by your logs. All right, here we go. Seat number 14.
Not here.
He's not here. Seat number 37. What'd you get? Just the answer. Negative 10, 74, 99ths. Like that? Agree, disagree? Okay. All right, so page 104, number 28 was, the problem was negative 10 and 74 hundredths as a repeating decimal. All right, in bar notation. So here we go. I'm going to go ahead and put my whole number first. So my negative 10, don't forget my negative. Of course, I'm then going to take this. There's two digits, right? So it would normally be 74 over 100. But because they're both, of course, that whole thing is repeating, I would put it over 99. And then we reduce. Can we reduce? No. So that's our answer. All right. Well done, guys. Any questions on those? Okay, so here's what you need to know. You might want to write down real quickly. Number 50, okay, where you know, pi, yeah, 3.14159264. Okay, it actually keeps going. Go ahead and write that down really quickly. All right, then you'll be able to use a little bit of that info. For those of you that can't remember, you'll use that info on there. No, I'm saying write that down because that's going to be needed info to help you solve number 50 that some of you may have forgotten since last year.
Are they gonna need the whole thing?
Maybe. All right. Okay, so as you guys know, we are, this is an introduction to rational numbers, okay? We define what rational numbers are, but there's different types of numbers, okay? So let me go ahead and start with, and there's actually different names of different types of numbers that you'll see in different books, or different mathematicians will call them different things, okay? But I'm just talking in terms of what our book is referring to, how it refers to everything, okay? So, the very first thing, okay, is, and you don't have, if you want to write this down, you can, you don't have to. The very first thing that, kind of some basic numbers are what's called natural numbers, okay? And natural numbers are kind of like your counting numbers, like 2 and 5 and 26, and those are your natural numbers, okay? Now, here's the thing. If you include the number 0 in that, so 2, 5, 26, and 0, now we're talking about something called whole numbers. Okay? So whole numbers, even though there's a 0 here, where you know, look at the natural numbers are inside the whole numbers because whole numbers are 0 and all natural numbers. That's how you read these things. Okay? Then, Okay? Then you get to 7th grade, right? And we talk about integers. So this is things like -1, -4, -28, whatever. Okay? Integers. Basically, when you're adding on the negative numbers, those are all called integers. Again, whole numbers are also called integers because they're inside the integer circle. Natural numbers are also called integers. Okay? Now, here's what you also have. In that little diagram there, okay, you also have this box, and that box is considered all rational numbers. And of course, where you get these rational numbers are things like fractions, terminating decimals, repeating decimals. But integers are rational numbers, whole numbers are rational numbers, natural numbers are rational numbers, all of them, everything inside that box would be considered rational numbers. But be careful, right? -1 is not considered a whole number or a natural number. Okay? So, any questions about how this box works? And how, okay. Now listen. If it doesn't fit in this box, they are not rational numbers, or we're going to use the prefix ir, or irrational numbers. Okay. Now listen, we will expand on this. We'll talk more about this diagram in a later lesson, but there is a part of your homework tonight that will ask you, give you a certain kind of number and say, list all of the things that this is. So for example, if I gave you, okay guys, what is -1? -1 is an integer, okay? It's a rational number as well. It's not an irrational, but it's a rational and it's an integer. It is not, though, a whole number or a natural number, okay? So it'd only have 2 answers rather than 5 or 6 of them or whatever, okay? Questions?
I have a question on a problem.
Okay, let's wait because we still are going to do some problems, okay? All right, I want to stay focused, and then if I still didn't answer that question after we're done, then let me know. All right, so you might want to, if those of you that didn't write it down, or even if you did write it down, okay, this little diagram is on page 103. Okay, it's similar to what I wrote down here. Okay, so in your book, it's on page 103. You're going to need that for these next set of numbers. Okay, so let's go ahead and let's make sure we're on 104. Let's take a look at problem 34. Okay, here we go. 34. 34 says, identify all sets to which each number belongs. So it goes with this thing right here. So here's what it is. It says 3.141516, and it just says ... So I guess it just continues. Now, first of all, it's not a natural number because it's not just a whole number. It's not a whole number. Okay, it's not an integer. There's no, I mean, we're not talking about a negative. What it is the decimal, right? Decimals are either going to be rational numbers or irrational numbers. But remember what the rule I taught you is that if the decimal does not repeat and it doesn't end, then it's not a rational number. This is an irrational number. Okay? So, any questions about, again, what this is going to look like or how to read this? I'm about to have you guys try one. And yes, there could be more than one answer on this, right? Because like I said, okay, -1 is considered an integer or a rational number, both of them. A 2 is considered a natural, a whole, an integer, and a rational number. Okay, so it's considered all of them. Okay, no questions? All right, here we go. I'm going to check in with you guys in about 30 seconds. I want you to try out problem 30. Problem 30, go. Anyone need more time on that one? Okay, 30 seconds. This is a really important one. You only have, there's no work to show, right? You just have answers by looking at the chart. So go ahead and share your answers with the person next to you.
I got natural.
Okay, here we go. All right, so remember, question is identify all sets to which each number belongs. So, see 32.
I got natural numbers.
Natural? Only one? Huh?
I only got natural numbers.
Okay. All right. Agree, disagree. Okay. All right. Couple of agreements, disagreements. Here we go. Oh, seat 39 is not in this class. Seat 3. Irrational? Yeah. Okay. Irrational. Sound like you said it right. Irrational. No natural. Irrational only. That's your answer? Okay. Agree, disagree. Okay. All right. Looks like we have some disagreements. That's okay. All right. That's why we do these problems. All right. Seat 28. Whole and rational or natural? Natural. Those two or more? Rational. Is that it? Okay. Agree, disagree. Okay, a couple more agreements. All right. Okay. Guys, here we go. I'm going to go ahead. Let's check this out. Okay? So the problem was 14. Well, here's what I would do is, where would it fit in this diagram? Would it fit in the integer part? As an example? No. Would it fit in the rational box section? 14 versus 1/18. Are those the same kind of numbers? No. Is 14 and like -1 the same kind of numbers? No, it's a little better, but not. How about 14 and 0? You have to be very careful. When you talk about a whole number, that 0 stands alone in that circle right there. That's it. It's just a 0. Because the rest would be in natural numbers. Is 14 more like 2 and 5? Those are like the numbers that, those are like the numbers that my 4-year-old says, right? I mean, when we're young, those are the numbers that we start with, okay? It's like those counting numbers, okay? Those are natural. It would fit in here. 14 would be in here. 14 is in the very center, so it would be natural. It's also in the whole circle, so it would be whole. It's also in the, I don't know if this is a circle or oval, but it's also in the integer oval, and it's also in the rational number box. It's all 4 of them.
I just put it
Okay? It's all four of them. So guys, first find out where the number belongs. And if we want to write steps on this, we can. I mean, step one is, where does it belong? Where does it belong in the diagram? You know, you have to identify it where it goes first. And then wherever it is, ask yourself, okay, ask yourself, oops. Okay, which ovals are around it? Because that will tell you which one it is. Now, of course, oval slash box, right? Because the rational number box is around it as well. So if it just happens to be in the integer box, then the natural and the whole numbers are circle or ovals aren't around it. It would just be the integer one in the rational number box. Okay, so you find its spot and then you work outwards from there, not inwards. Okay, that's another way to explain it. Okay. All right, I'm going to go ahead and shut the video down, the lesson, but I'm going to actually have you guys, while I do that, I'm going to give you guys 30 seconds. I want you to try out problem 32. I want you to try that one out. Now that I've explained the diagram, go ahead and try it out.